Okay, so hello everybody. This will be the lesson, another tutorial for another proving. This is not quadratic proving anymore. This is actually we'll begin to discuss for the um we will begin to discuss in this matter with this double hashing. So, as according to our class before that, double hashing is we will begin to actually get many states for that first. We'll begin to get the hash one, then the hash two, then the index. So we have the here the hash one, this formula, and the hash two, this formula, and the index position where we can put that one. So suppose that we do have the m is equals to 10 and r is equals to 7. R is actually the any prime number which has the lowest low value than the m. So 7 is actually good um already here, so we'll begin to just see what will be the locations for this accordingly. Okay, so let's run through for this in a step-by-step manner. So insert 44. So for 44, you will begin to run through with the hash one first. For hash one, 44, this is the formula. Then the m is 10. So therefore, just checking first, 44 divided by 10, that is 4. And 4 times 10, that is 40. 40 minus 44, that is 4. So therefore, that's how it works. Now, you will calculate the hash 2. Hash 2 formula is like this. R is set to 7 minus, the key will be 44. And then modulo over R. So therefore, since modulo is R, so that it will be better, let's try to grab a calculator. So that will be good. Now, so we do have 44. Why putting R? R is set to 7. So it will be like that. So you will begin to do 44 divided by 7. Okay. Now 7 is it will be 6. So 7 times 6, that is 42. 42 minus 44. So we do have remainder of 2. So therefore it will become 7 minus 2 for this one. 44 modulo of 7. It is 2. Now, 7 minus 2. 7 minus 2, it is 5. So therefore, this is our result. Now, for this one, you will begin to get the index using the formula of the index, which will be the hash 1 is 4 plus the I. I must begin from 0 to the n value. So since 0 right now times 2 the hash 2, that is 5. So therefore, this is 4 plus 0 because we'll deal with this, and that is still 4. Now, checking the index number 4, if it is empty, so we can just simply say um, in your 4 here that is empty, you can just say empty and then allocate 44. So this is the calculation. 44 will be stored here. Now, afterwards, once we'll begin to calculate 94, insert 94. Now, H1 will become 94, the modulo of 10, and 94 divide 10 is 9. 9 times 10 equals 90. 90 minus 94 is 4. So it will become 4. Now, your hash 2 is definitely 7 minus 94 modulo of 7. So let's try to get 7 minus. So 94 modulo of 7, 94 divide 7, that is 13. So 13 times 94. No, no, no. Times 7. So 91 minus 94. So therefore, the answer is 3. So the modulo is 3. So 7 minus 3, that is 4. So therefore, your hash 2 is 4. Now, calculating the index, index will become the hash 1 is 4. Then plus the 0, then times the hash 2. So it will become 4 plus 0, and that is 4. So your 4 right now, that is actually taken. So of course, you will be going to um run through with this one. Your I is set to 0 earlier, so we're going to increment that. It will become 1 times 4. So therefore, it will become 4 plus 4 equals 8. So let's try to see index number 8. Index number 8 is empty, so we can just simply allocate right there the number 94. So 94 will be inserted in your 8. So look how it jumped into the highest value into your calculation. This is really good. And afterwards, we're able to insert 94. We're done with this 2. We'll proceed to the 64. Insert 64. Now, hash 1 will become 64 modulo of 10. That is 64 divided 10 is 6. 6 times 10 equals 60. 60 minus 4, 64 is 4. So the modulo is 4. Hash 2 is equals to the 7 minus the here is 64 modulo of 7. So therefore, 64 divided by 7, that is 9. 9 times 7, that is 63 minus 64. So we do have 1. So therefore, 7 minus 1, it is 6. Now, calculating the index right now here, um, your index is 4, then plus the 0 times 6, your hash 2, that is 4 plus 0, that is 4. 4 is taken, so therefore you have to proceed. So you will proceed to 1 times 6. So it will become 4 plus 6, it will become 10. So 10 is actually more than the value of your bucket. Get the modulo. So it will become 10 divided 10, 0. 0 minus 0 is still 0, of course. So index number 0, you will just put here empty, and then allocate the number 64. So we'll insert 0, 64. We're done with the 64. Let's proceed to 74. So insert 74. 74 will be calculated. Hash 1 first. Don't forget that we're using hash 1. So 74, 10 will become 74, divide 7, 7, 7 times 10, 70, 70 minus 74 is 4. And your hash 2 is 7 minus the 74, then modulo of 7. So of course, 7 minus what will be 74 divided by 7, that is 10. So 10 times 7 equals 70 minus 74. So we do have 4. So 7 minus 4, it will become 3. So therefore, your hash 2 will be 3. Your index right now will become 4 hash 1 plus 0 times 3. So therefore, it will become 4 plus 0 and equals 4. 4 is actually taken, so therefore, we will run through. So it will become 4 plus increment as I will become 1 times 3. So 4 plus 3 will become 7. So let's try to check your index number 7. Sorry, it went off. So just let me just fix that for a while. Okay, so that is 4 plus 3. Okay, my color, my pen. Okay, now it will become 7. Checking index number 7, that is empty. So empty, it will be allocated in your index, which will be the 74. So 74 will be allocated here then. So we were able to handle effectively the hash collision. So we're done with 74. Let's go ahead and run through 18. So 18, let's try to run through in different location. Insert 18. Now, 18 for hash 1 equals modulo of 10. So 18 divided by 10 will become 1. 1 times 10 will become 10 minus 18 will become 8. Hash 2 will become 7 minus 18 modulo of 7. Of course, is 7 minus, okay, 18 divide 7, that is 2. 2 times 7, that is 14, minus 18, that is 4. So therefore, 7 minus 4, now it will become 3. So pertains to the index, we will be going to go ahead and hash 1, 8 plus the 0 times 3. So it will become 8 plus 0 and equals 8. So checking index number 8. So index number 8 is allocated already. So taken. Now, what we're going to do, 8 plus 1 times 3. So therefore, it will become 8 plus 3, that is 11. So 11 is more than the bucket. So 11 over 10. So 11 will become 1 times 11 divided 10, 1 times 10 equals 10, 10 minus 11 equals 1. So therefore, index 1, let's try to check index 1, that is empty. So therefore, we can insert in your index 1 this 18. Okay, so insert, this is empty, and 18. So index 1 is 18. Now, after 18, we will be going to insert 28 right now. So 28, so insert 28. 28, so sorry, hash 1 was 28 modulo of 10. 28 divided 10 is 2. 2 times 10 equals 20. 20 minus 8, 28 plus 8. And hash 2 will become 7 minus 28 over modulo of 7. Now, 7 minus, so 28 divided by 7, that is 4. 4 times 7, 28. So therefore, it will become 0. Now, 7 minus 0 equals 7. So index will become 8 plus 0 times 7. So of course, it will become 8 plus 0 equals 8. So index 8 is allocated. So therefore, we just have to keep on a loop. 8 plus 1 times 7 will become 8 plus 7. So it will become 15. So 15 modulo of 10 will become 15 divided 10, 1. 1 times 10, 10. 10 minus 15 equals 5. So therefore, index number 5, let's try to 6, let's try to check next number 5, that is empty. So therefore, we can allocate this value, which is 28, into your index number 5. So index number 5, 28, allocated there, and then we are done with 28. 30, let's try to check 30. Insert 30. So hash 1 is equals to 30 modulo of 10. So of course 30 divide 10 equals 3. 3 times 10 equals 30. 30 minus 30 equals 0. So hash 2 equals 7 minus 30 modulo of 7. So of course 30 divide 7 equals 4. So 4 times 7, that is 28, minus 30, that is 2. So therefore, it will become 7 minus 2, that is 5. So your index right now will become 0 times plus 0 times 5, and then 0 plus 0 equals 0 still. So for 0, let's try to check index 0 that is allocated. So taken. So what can we do? You just have to 0 plus 1 times 5 equals 0 plus 5. It will become 5. So checking index 5 that is allocated also. So taken. You just have to run through again. So it will become 0 plus 2, because we're done with 1 earlier, times 5. It will be incremented, as what I have mentioned. So 0 plus 2 times 5 equals 10. So therefore, it will become 10. Now, 10 is more than, it will become 10. Modulo of 10, it will become 0. So it actually loops back. So 0 is allocated already. So that is not that is not empty, that is taken. So what can we do? Since this is loop here, then earlier we're able to have that. Let's try to check again for the this one. We will just have to run through. It will become 3. Let's try to check if this will still be having a looping. So it will become 0 plus 15. So equals 15. So since 15, checking the modulo over 10, that is 5. So therefore, it keeps on looping again. So earlier, we're able to have 5. So since 5 is taken, so what can we do? We will be going to deal with that. So since this is the first 5 and second 5, then first 0 and second 0. So we're able to have a data collision really that much. And then right now, let's try to run through for the fourth one. 4 times 5 will become 0 plus 20, and 20, it will be the same thing. 20 over 10, it will become 20, it will become 0. So this is another, this is taken. So another, so this is third time. So since that is third time, just what you just have to do, cannot you just have to explain for the 28, for the 30, that we cannot allocate because of looping statement. Okay, so just have to explain further what will be the key role, or I mean, what is the main reason why we cannot allocate that into the specific table. Okay, hopefully that you were able to understand the process for the double hashing. I know that this is really not really so long, but that is really how it works. So thank you so much and goodbye for okay, let's try to see. We're not able to allocate the other. So we're able to allocate effectively the 44, correct. Then 94 here, 64 is here, 74 is here, 18 is here, 28 is here. So 30 is the only thing that we cannot allocate that one. So I'll be going to perform the searching in the other video, which is only one. Okay, thank you so much and goodbye.